Hello everyone. So today I'm going to discuss the merge sort algorithm. So let's discuss what is merge sort and how we do it. Okay. So merge sort. Okay. Suppose you are given an array 2, 1, 6, 3, 9, 4, 5, and 10. And you need to sort this array. So there are other algorithms to sort this array. One is bubble sort, but the problem with the bubble sort is the time complexity of bubble sort is O of n square, which is too much. Another is selection sort. Again, the time complexity of selection sort is big O of n square, same as the bubble sort. And then there is an insertion sort whose time complexity is again O of n square. So we need some algorithm which is better than O of n square, and that's the merge sort algorithm. So with the merge sort, what we do is we divide the array into the two halves. So that's one half and that's another half. Then what we do is we keep dividing the array into two. So we again divide this first half into another two. So now the array that we have is 1 2 1 6 3. That's the left part. And then we have 9 4 5 and 10. That's the right part. And then we again divide this left half into two. So we will have 2 1, that's the left part, and then we'll have 6 and 3, that's the right part. Then we'll again divide this into two left half and the right half, which will be 9 4, that's the left half, and 5 10, that's the right half. Then again we are going to divide this. So we'll have 2 as a left half, 1 as a right half. Again we are going to divide this, so we'll have 6 as in the left half, 3 in the right half, 9 in the left half, 4 in the right half, 5 in the left half, and 10 in the right half. So now this 2, right, we cannot divide it further, right? Now we have only one element, so now we cannot divide it further. So what we are going to do is we are going to merge this left half with the right half. Okay, and the logic that we are going to use for merging is we'll check if this element is less than 2, then we'll create a list where we'll add 1 and then we'll add 2. So now we have a list which contains, or array which contains 1 and 2. Then again we'll merge this two, 6 and 3. So we'll create a list which will have 3 and 6. Now this list is sorted. 1 and 2 is sorted, 3 and 6 is sorted. Now we are going to merge 9 and 4. So the list will have 4 and 9, and this list is sorted. Then we are going to merge 5 and 10. So the list will have 5 and 10, and this list is sorted. Now we are going to merge this two lists. This one, left and right. This two lists we are going to merge. So we'll take this element number 1 and 3. We'll compare which one is smaller. 1 is smaller, so we'll add 1 to the list, and then we'll move on to 2. We'll compare 2 and 3. 2 is smaller, so we'll add 2 to the list. Now we are done with this left list, so we'll just add all the element of the right list as it is. the right list is already sorted, so we'll just add all the remaining elements. So now we got a list 1 2 3 6 and this list is sorted. Now we are going to merge these two lists 4 9 and 5 10. So I'll compare 4 with 5. 4 is less than 5, so I'll add 4 to the list. Then I'll compare 9 and 5. 5 is less than 9, I'll add 5 to the list. And then I'll compare 10 and 9. 9 is less than 10, I'll add 9 to the list. And then I have remaining element which is 10, which I'll add to the list. And now I have this list which is sorted 4 5 9 10. Now I'm going to merge this two lists. So I'll compare 1 with 4. 1 is less than 4, so I'll add 1 to the list. Then I'll move the pointer and I'll increment by 1 and I'll compare 2 and 4. 2 is less than 4, then I'll again increment this. 3 is less than 4, then I'll increment this, and then 4 is less than 6, so I'll add 4 and I'll increment this. Now I'll compare 5 and 6. 5 is less than 6, so I'll add 5 to the list. I'll increment this. Now I'm comparing 6 and 9, so I'll add 6 to the list. Now I'm done with this list. There's no more elements here, so I'll just add the remaining elements, which is 9 and 10, and that's how I got the sorted list. Now what is the time complexity of this algorithm? So if you look at this algorithm, what we did, if I have n elements here, right, I divided it into n by 2, n by 2. Then I again divided it into n by 4, n by 4, n by 4. And I further divided it into n by 8, 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 n by 8. Right? And that's how I got only one element at the last. So if you look at this tree, okay, so we are dividing the work into half. So we divide the work into half here, then we made it divided, further divided into half, further divided into half, right? So at each step the work is divided into half. So the time complexity, right, of dividing is log n. But then after we are done dividing it, we need to merge it, right? So we need to merge all the elements, right? And the time complexity to merge is n, right? Because we need to merge all the elements here. So the time complexity to merge is n, and the total time complexity, right, is n times log n, which is of course less than n squared, right? So that's the time complexity for the merge sort. Now the merge sort is also called divide and conquer, because what we are doing is at every step we are dividing the array into half and then we are merging it. So it's also called divide and conquer algorithm. It's also called divide and conquer. So what are the steps of for writing the merge sort algorithm? Let's discuss that. Okay, so what is the first thing that you are going to do is, let's see. Okay, so the first step that we need to do is we need to divide the left half and divide into right half, right? Divide into right half, and then the last thing that we do is we merge both the left and right half, right? Now the time complexity, as we discussed. It's O of n log n, right? And what is the space complexity? So while we are merging, right, we are creating a new list, new merged list, right, which takes O of n space. And when we are dividing, we are making the recursive call, right? When we are dividing into half, we are making every time we are making a recursive call. So that takes log n stack space. So the overall space complexity is O of n log n. So n log n is a stack space and n is the space that is required for merging. Now this algorithm maintains the order in case of duplicates. So for example, let's take one example here. So you have a duplicate elements here. For example, let's take this. You have 2. Let's do this. You have 2a, and then you have 1, and then you have 6. Then you have 2b, and then you have 3, and then you have 9, right? So we have duplicates here. We have 2 here and we have 2 here. But when we sort this array, the order of this 2a and 2b will be maintained. That means the 2a should come before 2b. So what happened in this case, right? You divide this, right? You divide this list into half, right? So we get 2a, 1 and 6, and another list we get which is 2b, 3 and 9. And you again divide this list into half and you get 2a. This is odd, so we'll just another list which is 1 and 6. You get this when you divide this, and when you divide this you get 2b and 3 9, right? Then you again divide this list into half, which will give you 1 and 6, and here you will have 2a, and this will give you 2b, and this will give you 3 and 9, right? So now when you merge, first you're gonna merge this two, okay? So when you merge this, you will have a list with 1 and 6, and when you merge this two, you will have a list with 3 and 9, and here you have 2a, right? And here you have 2a. Now you are going to merge this two, right? So the pointer is here, 2 and 1, so you compare, okay? 1 is less than 2, so 1 you add 1, you increment this, and then you see, oh, 2 is less than 6, so I'll add 2, and then I'll add 6. So you got this list, and then you merge this two, so you have a pointer here and pointer here, and you see, oh, 2 is less than 3, so 2, oh sorry, this is b, no, this is, it's b, okay? So 2b, and then you add 3, and then you add 9. Now you got two sorted lists and you merge them, right? So the pointer is here, 1 and 2, and you see, oh, 1 is less than 2, I'll add this 1, and you increment this. Now the pointer is here, so now when you compare, you see that 2 is less than this 2, right? The left half, the 2 which is in the left half is less than or equal to the number which is in the right half. So the condition for comparing is less than equal to. So this 2 is less than 2a is less than equal to 2b. So you add 2a and you increment this, and now you compare 6 and 2b. So of course you add 2b and you increment this, and you compare 6 and 3, so you'll add 3, and then you compare 6 and 9, so you'll add 6 and 9. And now the list is sorted, and look at the order of for the duplicates. So 2a was before 2b, and that's how you got it. So you got 2A before 2B when the list is sorted. So it maintains order in case of duplicates, right? And the algorithm that maintains order, the sorting algorithm which maintains order in case of duplicate, is called a stable sorting algorithm. So merge sort is a stable sorting algorithm. Now let's write code to see how we actually do this. Okay, so we have public void, we have our merge sort algorithm, and I'm passing the array, integer array. My array is not sorted, I need to sort it, and I'm passing left and right. So when I call this function, if I have array of size 6, right, for example, my left will be 0 and my right will be 5. it, it will point to the leftmost and rightmost element in the array. Now what is the first thing that I have to do? I have to divide it into 2, right? But I need to do that only when if there are more than one element, and if there are more than one element, that means left is less than right. If left is less than right, then only I'm going to divide, otherwise I'm not going to divide. Then I'll calculate the midpoint where I'm going to divide. So that will be integer m is equal to left plus right minus left. So we got our mid, and now we are going to divide it into the left half and right half. So we are going to recursively call merge sort with an array A, and my left half starts at left till the midpoint, and then my right half will be mid plus 1, and it stops at the right most position. And after I'm done dividing it into two halves, the left and right, what I'm going to do is I'm going to merge both of them. So that's my array, and I'm saying that this is my left, mid and right, and I need to merge them now. So in order to merge it, right, let's write the merge function. So public void merge, and then you have integer a, which is my array, and I'm saying that this is my left, this is my mid, and this is my right. And in order to merge it, I need to first, I'll create two lists. I'll create two array with the left half and the right half, and then I'm going to do my merge logic. So what will be the size of the array, the left array? What will be the size? It will be mid minus left, right? So if mid is 7 and left is 4, then 7 minus 4, which will be 3, but it's actually 4, 5, 6, 7, so it's 3 plus 1. You need to do that. So mid minus left plus 1. So that will be the size of the left array. And what will be the size of right array? That will be right minus mid, right? So if, let's say, if the rightmost position is 9 and mid is 7, so 9 minus 7, which will give you 2, so the right array will have 8 and 9. I'm just saying index 8 and 9. So I'm going to create a two array, the left array, and the size of the left array is n1, and then I'm going to create a right array, and the size of the right array is n2, and then I'm going to add all the elements in the left array and the right array. So for integer I is equal to 0, I less than n1, I plus plus, I'll add the elements in the left array, which will be a of, so the first element in the left array will be array of L, right? So it will be actually, and then the next element will be L plus 1, L plus 2. So it will be L plus I, right? And that is my left array. Now I'm going to create the right array. Integer I is equal to 0, I less than n2, I plus plus, and the first element in my right array will be mid plus 1, right? And then mid plus 1 plus 1, mid plus 1 plus 2, like that, right? So it will be a of mid plus 1 plus I, right? So now I have left array and right array, both are sorted. I need to merge them. So how I'm going to do? I need to apply the merge logic, and when I merge this both arrays, I'll add the element in the existing array only. So I'm not creating a new array, new merged array. The sorted elements will be added in the existing array only. So let's write the merge logic. I is equal to 0, integer j is equal to 0, and the k will be L, which is in the original array A. I'll start adding the merged elements, which will start at position L. So while I is less than n1 and j is less than n2, right? I is for list 1, j is for list 2, array 2. And now I'm going to compare both the elements. If L of I, remember less than equal to condition for us to get a stable sorting algorithm, less than equal to R of j. If that's the case, then what we are going to do, array of k, right? We are going to add which element? L of I, right? And then we have to increment I plus plus, right? And if this is not the case, right, then what you do? Then you add the right element in array of k is equal to R of j, and you increment little j plus plus, and then you are done. And then you also increment k, right? And this way you'll add all the elements, and then if you have any remaining elements, right, as I said, if one array is done and you've still got some remaining elements in the other array, you simply add it, because that array, that list, left or right list, whatever it is which has a remaining element, it's already sorted, so you just simply add it. So while I is less than n1, if the first left list is not completed, there are some elements, then you just simply add it. A of k is equal to L of I, and then you do I plus plus and k plus plus. You'll never have both the lists you'll never have both the lists not completed. One list will be completed and the other might not be completed. So there is no way you can have both the lists not completed. So now if the second list is not completed, right, so while j less than n2, right, to add k of k is equal to r of j, and then we do j plus plus and k plus plus. So now we have added all the remaining elements. So this is how you do merge sort. So look here we are dividing, we are recursively calling this. So if I have 8 elements, I call this, this will call with 4, and this will call with 4, then again that will come here, it will recursively call this, and then it will again 4 will be divided into half, so it will be 2, and then again it will come here and 2 will be divided into 1, and finally when there is one element, so this will have one element and this will have one element, so it will do nothing here, it will not go here, and then we'll have one element here in this list, one element here in this list, and then we'll merge it. We'll call the merge function to merge the single element in left list and single element in the right list. We merge it and we create a list with the 2 element, but we are not creating a new list, we are just adding those 2 elements in this array A only. So we are just adding, we are merging it and adding it in the same position in array A. But this is how you do the merge sort. And thank you so much for watching the video. I'll come up with some more sorting algorithms in my other videos. Thank you.